Good day, everybody. Welcome to this session of Cloud Lunch and Learn. I'm your moderator, Dwayne Natwick, and welcome to this great session. Andy Cutler is gracious enough to give us some insight into understanding SQL in Fabric Synapse data warehousing. Really looking forward to seeing this session. I've worked a little bit in Fabric with doing some of my training courses in data fundamentals. So looking forward to seeing a little bit more about how we can utilize Fabric and what we can do with it. So with that being said, I'm going to turn it over to you, Andy, and have a great session.
Brilliant. Thank you very much. Well, firstly, you can hear me okay?
All good.
Good stuff. Thank you very much, Dwayne. And yes, Dwayne actually, just as we were talking before, Fabric has now found its way into some of the certifications that are not just the DP 600 Fabric Analytics Engineer. So now it's in DP 900, the Azure Data Fundamentals. So if you haven't done that DP 900 yet, Fabric's all part of that as well. So that's going to be a really great thing. But yes, let's crack on. So welcome. The two become one in the session title is going to make sense when I get to a specific slide. But ultimately, this session is about understanding the Fabric warehouse service. And why is it there? And how have we got to where we've got to with this seemingly brand new service? So actually, the agenda we'll go through is we're going to touch on a little bit about what Fabric is. That's not the subject of this session because what is Fabric is a whole session and a whole day in and of itself. So we'll keep that very short because I want to dive into the warehouse service. I want to look at the T-SQL or the SQL timeline, the engine timeline of where we've got to. Look at the SQL engine itself. So what's underpinning this new engine in Fabric, and well, why is it there? Why do we want to use this? Why have Microsoft created this service? And we'll jump in to a demo as well, because you can enable Fabric, you can get started with the warehouse service. There's an example warehouse that you can spin up, already got some data in there. I've also created a script based on that has some better names that I like to use. So we'll show that. And all that good stuff. So a little bit about me. My name is Andy Cutler. So I work for myself as a independent contractor and consultant, specializing really in the Microsoft data space, SQL Server, Azure, data platform, Microsoft Fabric. And just to call out a conference that I'm a co-organizer of. So if you go to datatoboggan.co.uk, we've got an upcoming conference which is on Saturday, July the 13th. It's free. It's virtual, it's online, and we've got 3 tracks. And we really specialize in Fabric and Synapse analytics, data engineering, data warehousing, but we've got sessions on Power BI, AI. Obviously, there's a lot of AI in the products now. So that would be great. So firstly, what is Fabric? Okay, I'm going to bring up a standard Microsoft image of what Fabric is, because really, I don't think I can do any better than that in describing Fabric in a single image. Essentially, Fabric is adding additional functionality to a Power BI tenant. And that's the way that I look at it. So we now have a data warehousing service. We've got data engineering, so we can bring Spark workloads and PySpark, Scala into the mix. We've got Data Factory for our data ingestion and transformation. We've got some real-time analytics that have been added in there. So anyone familiar with Custo and Data Explorer, so that real-time engine now exists within Fabric, within the Power BI tenancy. And of course, Power BI as well. Yep. So Power BI does not change as a product. We've just had this functionality added. Now, in terms of the compute around Fabric, we've got a universal compute engine or universal compute that we're using. All the different engines, so whether it's Spark, whether it's the SQL endpoint service, they're all using this compute. So we're not having to buy lots of individual compute to run each engine like we would with Synapse Analytics, for example. So we're purchasing a certain number of these capacity units to be able to run our workloads. Most of the control of the engines is abstracted away because fundamentally this is a software as a service platform. You don't really have many dials and switches to turn in terms of configuration. You do have within Spark. So Spark is configurable. You can create different sizes of clusters, types of clusters, install libraries, so on and so forth. But for the SQL services that we're going to concentrate on in this session, we don't really have a lot of control. The biggest departure is the technology that underpins the storage. So, we're going to talk about this concept of decoupled compute and storage. Microsoft have gone in on the Delta Lake format to handle the transactional consistency and work with the file based data. So, data is stored in Parquet files. We'll touch that on a bit. But that's one of the biggest changes in terms of how data is being stored in a SQL based service that Microsoft have launched. So, in the Fabric warehouse itself, so yes, this is a software as a service data platform. Now, for the Fabric warehouse specifically itself, think about modeled data. And when I mean modeled data, I mean star schema data, dimensionally modeled data. This is where the warehouse really shines in a data platform, right? So this is not a service that you're going to create a line of business application that's very highly transactional, lots of individual inserts and updates and deletes. This is an analytics platform. And like I said before, we've got no configuration in the warehouse at this stage. And things like running queries, you don't really have much control in how they're running the queries. Yeah. You're essentially trusting Microsoft in delivering a quality of service via the warehouse. But you can still use common objects. You can create tables, columns, you can create store procedures, functions, views, but there's a subset of functionality. Now, this whole concept of separating compute and storage, what Fabric has essentially brought to the table is all these different engines, whether it's Spark, whether it's the SQL service in the warehouse, Power BI, all have this layer of storage, this logical layer called OneLake, which is essentially Azure storage under the hood. Now, this storage for the warehouse service is managed by Delta and manifested as Parquet files under the hood. And that means that other engines can come along and read the data from the warehouse. So, for example, if you have Databricks, then Databricks can come along and read the data that's in that Fabric warehouse. Can't write to it at the moment because the warehouse is controlling that writing of the data. And yes, as I said, uses the open source storage format Parquet, which is a compressed file format. And Delta is bringing transactional consistency. So, one of the problems and one of the reasons why Delta has been brought into these products is as the middle layer. So, when engines are reading and writing to files in a data lake, Delta sits there to make sure that transactions are committed or rolled back and that your data is not left in a corrupt state. Now, when we install a product like SQL Server, or we deploy a service like Synapse Analytics, we get given a server name to connect to or a URL to connect to. Fabric warehouses, it's the same. So if we create a workspace within Power BI, and if we create a warehouse, we'll get an endpoint that we can use to connect to. So there we go. I've added lots of different items to a workspace. Okay. Now we're not going to go through all those items. We're just looking at the warehouse service. But look, tons and tons and tons of different types of items I can create in a workspace. How does that look if I connect to that workspace using a SQL client tool like SQL Server Management Studio? Well, it looks like a server. So those data warehouse or those Fabric warehouses, they show themselves as databases. So that's how I kind of like to think of workspaces. Yeah, they're at the server level. But several workspaces could be using the same Fabric capacity, the same compute. And we've got options within tools like Azure Data Studio to use database projects. So within database projects, we've got functionality to be able to create a database project, build it, and deploy it into the Fabric Warehouse service. So you can integrate it into part of your database deployment CI/CD. In terms of the concepts, some of these already exist, right? From, let's say, SQL Server for many years. Others have been added in because of the storage technology that is now being used, plus some other features that are being added into the service as well. So I want to cover the fact that, well, there's a cache, right? Caching is good. With a warehouse, you don't really want to have to keep going back and getting the same data over and over again. So we've got an in-memory cache. However, if the data set is a little bit too large and won't fit in that in-memory cache, it'll get stored in a super fast SSDT for retrieval as well. So we've got multiple levels of caching available within that warehouse service. We've got statistics. Everyone who's worked with SQL Server or database products know statistics help the engine search for and get the data as quickly as possible. We can leave Fabric Warehouse to do its thing and create automatic statistics, but we have control ourselves. We can create statistics if we think we're better than the query optimizer, but we need to manually update those statistics or create a process to do that for us. With workload management, we don't have any configuration yet in terms of being able to limit what the warehouse is doing in terms of how much compute it's using. But there is a concept of workspace boundaries. So if you've got workloads in different workspaces, there's a boundary there in terms of performance. We don't want noisy neighbors in terms of workloads. And this is where we start to see some of the features that Delta Lake offer. So one of the features of Delta Lake, amongst many, is the ability to time travel, i.e., if data gets updated in a table and you see the current set of data, you can go back and look at the previous data. Last hour, a few days ago, in the warehouse service in Fabric, that's currently limited to 7 days. So don't get excited and think, oh, I'll use time travel and it'll keep a history of my data for all time. No, it'll keep it for 7 days, then it will go. Very useful if you want to go back, maybe snapshot some of the tables at a specific point in time. So it's very important to note it's got a 7-day retention policy on that. We've got semantic model integration. So Microsoft renamed Power BI datasets to semantic models. And one of the new features in Power BI when Fabric was released is this direct lake connectivity. So really there were two connectivity methods with Power BI: import and direct query. Import, as the name suggests, we're connecting to a data source. So that could be a database, a file system, and we're loading data into the Power BI engine itself, direct query, we're sending, or Power BI is sending queries down to a supported data source. The data source itself is running those queries and then returning the data set. Benefits of import, it's fast when retrieving results. Drawbacks, you've got to load the data in. So you've got to spend time loading the data into the model again. Direct query, benefit, low latency. As soon as data hits that source that Power BI is connected to, refresher report comes through. Drawbacks, and there are many, is that direct query can be quite heavy on the source system and can choke up the source system if lots and lots and lots of queries are being sent down there. Performance bottlenecks, essentially. I always found ways to mitigate that and use it for a specific purpose. Direct Lake gives us the benefit and speed of import with the latency of direct query. So we've got cloning. Again, this is some functionality that's available because of the Delta Lake platform that's being used, or feature that's being used. Now we've got a shallow table cloning, and basically what this means is you can create a clone of a table. It acts like a separate table. You can modify data. You can modify the schema of that cloned table. It won't affect the base table. So it's a really, really good way of maybe snapshotting a table, maybe taking a table away and doing some development or testing on it, backing up purposes, but very, very lightweight operation. The warehouse does have some guardrails, so it won't. So Fabric has a concept of bursting and smoothing, in that if you purchase a specific sized Fabric capacity, if during a period of the day you just need a bit extra, Microsoft are not going to penalize you. They're not going to fail your jobs. Your capacity will temporarily burst beyond its limit to get that workload done, and then you pay it back later on when your capacity is a little quieter. But with Fabric Warehouse, it's not just going to go crazy and burst uncontrollably. It's got some guardrails, and that's all going to be dependent on the size of SKU. It's not going to go crazy and burst 1,000 times beyond its limit, and maybe leave you in trouble. And look, I can't mention a Microsoft service without mentioning the fact that Copilot's going to be coming in there soon. How does this relate to SQL? Well, so the Copilot within the warehouse will help you write your SQL against that warehouse by understanding the warehouse itself and the tables and columns and data that's in there. That's coming soon. In fact, you can sign up for the preview. So if you search for Microsoft Fabric Warehouse Copilot, you'll likely find a page to do that. So in terms of the timeline, this all starts somewhere. And over 20 years ago, there was a guy called Stu Frost, started the company called Data Allegro, used some open source software, so Ingress and Linux, so Ingress database software and Linux. And essentially, the company created a large scale data warehousing platform to compete with the vendors at the time, because the vendors at the time, large scale data warehousing was very, very expensive, prohibitively expensive for a lot of people. They saw a gap in the market, created this product. So who came along and bought them? Microsoft. So Microsoft bought the Data Allegro, wrapped in a bit of SQL Server, magic wand, out pops Parallel Data Warehouse, or PDW, 2008 to 2010. And essentially, this was, again, an installable appliance. So people would come and install this appliance in your data center, and you could run large scale, multi terabyte data warehousing. It did advance after PDW into the analytics platform system and add ability to read from the data lake. But the next significant upgrade was essentially deploying that appliance into the cloud. So that's why we got Azure SQL Data Warehouse. So both Gen 1 and Gen 2. And that was the game changer, really, because that then enabled you to run multi terabyte warehouses in the cloud. Yes, it was a very considered and specialist application. You had to understand how to balance your data, distribute your data, but it gave you incredible power to all of a sudden be able to work with terabytes of data in an engine that was designed specifically for that. A few years later, Microsoft announced Synapse Analytics rebranded SQL Data Warehouse to now be called Dedicated SQL Pools. And they brought the Gen 2 version in there. Part of that is that Microsoft then created a new engine called serverless SQL Pools. Essentially, serverless SQL Pools didn't store any data itself, didn't have a system to store data. Yes, it had the concept of TempDB to store result sets, but you are essentially connecting to and querying data in the data lake. So, very, very useful to cast structure over data that was stored in a data lake. In Parquet, using Delta, CSV, JSON, but you could only really read the data. You couldn't work with it, you couldn't manipulate it, edit, update, couldn't do any of that. So now we have Fabric SQL. And this is where the two becomes one, or two becomes one comes into it. Because with Synapse Analytics, all of a sudden we had two SQL endpoints to work with. We had the warehouse endpoint, in that we loaded data into a relational engine. We had another SQL endpoint in which we were querying data in a lakehouse. And the two didn't really work together. So this engine that we now have in Fabric is an enhanced version of the engine that we see in serverless SQL pools, in that now we've got CRUD abilities. So we can create tables, we can update tables, we can insert data, we can delete. Couldn't do that with serverless. There was some basic writing functionality, but nothing like we see now. So dedicated SQL pools stay in Synapse Analytics. The name Synapse has continued into Fabric, and that's why we have Synapse data warehousing. So in terms of the SQL endpoint, what Microsoft have created is an engine in which, when it receives a workload, a query, a SQL query, could be inserting data, could be selecting data, the query optimizer or the query engine basically works out, oh, how many compute nodes do I need to run this workload? Creates those, spins up those back-end SQL pools, runs the workload. If there's any problem, so for example, a node goes down, another node will pop in, the work gets rebalanced, and it'll carry on. As I said, it started life as serverless SQL pools. We can now read and write data, the crux of the warehouse service. And there is a white paper. So it was submitted to the VLDB conference, the very large database conference. And this outlines this distributed and fault tolerant engine, where essentially data is split up into a number of cells. These cells are given to compute nodes to do the processing, and then everything is returned in a result set and delivered back. It's around 10 to 12 pages long. And if you really want to understand what that engine is doing, that white paper is a great place to start. Now, what Microsoft have done is they've added some isolation boundaries in the warehouse service. So if you're ingesting data, but you're also querying data, the two are not going to impact each other. So they've added an isolation boundary in there. But essentially, we've got a front end that we're connecting to, an endpoint. That's going to send the query off to the DQP, the distributed query processor, which essentially figures out how much compute it needs to complete a task, runs the task. Now, with a SQL endpoint, it actually does mean two things. So when people talk about the Fabric SQL endpoint, they could mean the warehouse service, but they can also mean the lakehouse SQL endpoint. So with Fabric, we've got the concept of the SQL endpoint. Now, lakehouse is a Spark construct within Fabric. Bring your Python expertise, your Spark expertise, create a lakehouse, load your data in, and you can use T-SQL to read that data. A little bit like using serverless SQL pools in Synapse over a data lake. You can't modify data using that SQL endpoint, but you query it using T-SQL. You can create views, you can create stored procedures and functions. You just can't modify the data in the lakehouse. But that SQL endpoint is also responsible for the warehouse service. And that's where you can write data. You can create objects. You can alter those objects. You can insert, update, and delete data as well as selecting it. But that SQL endpoint is exposed to client tools. So you can use Management Studio to connect and run SQL queries. Now, in terms of storage, like I said, this is the biggest departure in terms of Microsoft building a SQL based service, is that we're using this Delta Lake or this OSS or open source Delta Lake technology to manage the process of reading and writing data to the storage. So ultimately, what does it look like within storage? It looks like folders. So if we connect using tools like Azure Storage Explorer, we'll see a bunch of folders with lots of GUIDs because essentially the Fabric service or the Fabric warehouse is managing this. You can't go in and just start deleting folders, just like you can't, if somebody had access to a SQL server, they wouldn't be able to delete MDF and LDF files. So the warehouse service is managing these files and folders. And the data is stored within the Parquet files, so a compressed storage format. Now, the difference is we've got a table. I don't want to spend too much time on that table. There's a couple of things I want to pull out that's relevant to the storage mechanism here. Don't want to go through this table too much. I want to call out a couple of things. So on the Fabric warehouse side, no, we don't currently have any partitioning ability. No, we don't have any indexes. And you might think, hang on a minute, we can't create indexes, but that's like the crux of databases, right? We've got to create indexes to speed up data retrieval. In the world of the warehouse or Fabric warehouse, the file format is in itself an index. It is essentially a column store index, a compressed data to aid with analytical queries. So we don't have the ability to create, let's say, non-clustered indexes over that data. The data itself is the index. And in terms of isolation levels, we've really only got one isolation level, snapshot isolation, which, I mean, if I had to pick a favorite isolation level, and it's because I work with data warehouses, I like snapshot isolation. It's very optimistic. Some say maybe too optimistic, but it's designed to allow as much concurrency in terms of reading and writing as possible. So readers are not blocking writers and writers are not blocking readers. However, some people might not like the fact that, oh, we've only got one isolation level. But that's because of the Delta Lake technology that we're using. So in terms of why, because it is different. If you look at a platform like SQL Server, it's a very mature product. been being used all across the world for decades. It's incredibly feature rich. I think I installed SQL 2022 the other day, and just the list of checkboxes for the various different features you can install. Wow, okay, lots of stuff in there. What you're getting with this engine in Fabric is a subset. It doesn't need all of those features that SQL Server has because it's not for those types of workloads. When I say it answers the awkward data size issue, with Synapse Analytics, there was a bit of a problem in terms of using, let's say, dedicated SQL pools. It was really a service that came into its own with large volumes of data because that's exactly what it was designed for. If you started to use smaller data sets, and I'm talking tens of gigs, even hundreds of gigs, you still had to be very considerate about how you distributed your data. You could still use it, but there was a tipping point, really. Once your data started to get into the terabytes, that's when that engine really started to shine. Obviously, with the Fabric warehouse service, any data size. Microsoft have tested with 100 terabytes in the warehouse service. Unfortunately, I don't have 100 terabytes to hand to test what Microsoft is saying. But from very small data all the way up, you're covered here. Microsoft stopped developing on dedicated SQL pools in Synapse, so we didn't get a lot of the things that we wanted. So no auto scale, we couldn't auto pause or resume. That development stopped. We've got this in Fabric Warehouse, as in terms of the warehouse is there available to us when we want to use it. It has made it more accessible. Obviously, this is all to do with permissions. You don't have to give permissions for people to be able to work with this service. But with a very few clicks in the Power BI portal, you can enable Fabric and people can start creating warehouses, right? So we'll look at those toggle very quickly when we jump into the demo. So has this given rise to citizen data developers? I'll let you answer that question because that could be a whole session in and of itself. And essentially, Microsoft were falling behind in terms of cloud data warehousing. Databricks were doing amazing things in their space. Snowflake as well. Dedicated just wasn't really cutting the mustard in terms of features that people wanted in their data warehousing workloads, i.e., they didn't really want to be paying when they weren't using it. So, in terms of loading options, obviously we've got code, we've got SQL, copy into. That was the fastest method of getting data into dedicated SQL pools. Same here in terms of the Fabric warehouse. That's if you're copying data from Azure storage. We can CTAS, create table as select, an equally performant way of loading data. So transform the data on the fly as you're creating a table. But we can insert into. Now, you might notice that if you're inserting very small amounts of data, like one row, that it's not maybe as quick as, say, SQL Server, because it's not really that type of engine. But we can insert into using select as well. And we've got options in terms of notebooks. So we can use ODBC from notebooks to connect to the warehouse SQL endpoint and work with the data there. So in terms of a couple of low code options, we've got pipelines and they're in quotes brute force. Don't really use pipelines to transform data that much, but it's good for getting data from one place to another. And we've got data flows, Gen 2, I should say Gen 2, which is based on Power Query. So Power Query existed within the Power BI ecosystem for many years. Microsoft have now put it front and center as an ETL/ELT tool. So let's jump in. So I'm going to open my Fabric workspace just going to bring my window into here. Just make sure that's up and it's zoomed correctly. Yeah, looks good. So I've already created a workspace within Fabric. Those toggles I was telling you about, if I go into the admin portal, I've got a setting. Users can create Fabric items. So that is the setting that let people create Fabric items. Now, best practice, create an Active Directory group or multiple Active Directory groups, however you manage your groups. Add the relevant users into that group. Add that group to this option. So if you're looking at a POC with Fabric and you're already using Power BI, then maybe you can assign a few users to a group and add that group here. We've also got trial, as in people can, if I go down to, yep, users can try Microsoft paid Fabric features. So you can enable a 60-day trial. What I would suggest is that one person creates a trial, create some workspaces, assign those workspaces to that trial. And the trial is essentially an F64 or a premium P1. Won't go into the compute too much, but it's not a small compute, but it's not the largest. Now, in terms of the workspace itself, so if we go into the workspace, so I've already created some objects here. So I've created a couple of warehouses because I just want to show a couple of ways of creating the warehouse. And I've got a lakehouse as well. So I want to show the SQL endpoint, but I'm also using that lakehouse to load data from it into my warehouse. So in terms of connectivity, there's nothing on this workspace that gives us the overall workspace connection for the warehouse services. We're going into a warehouse itself and looking at this connection string. All right, so if I copy that connection string, copy connection string, I'll copy that. That actually is one single, I'm going to open Management Studio. That's one single URL to connect to that workspace. It's not specific to that warehouse. So you can go onto the SQL endpoint in a lakehouse, any other warehouses that are in a workspace, get that connection string. It's the same. So let management start up here. And if I connect to the database engine, use MFA, connect up to my user. Probably going to have to use my MFA for this. It's asking me for a password. I'm going to leave that there. Actually, I think I had SSMS 20 installed, but no. Okay, fine. So when I'm working with the warehouse service, I can create a warehouse pretty easily. New, or switch to my warehouse persona down the bottom left. Click new, click warehouse. Give my warehouse a name, click create. I won't do it here. And you'll end up with a warehouse that's created. You do get this default semantic model, and we will have a look at that. But basically, Microsoft are creating a Power BI semantic model for you to use against the data in the warehouse. There are some issues with using that default semantic model. So it's not really recommended, or I wouldn't really recommend using that model to build your business facing semantic model. You can create another semantic model or a custom semantic model and work with the warehouse service the same way. So if I go into this sample warehouse, I've got a script. And what this script is, it's actually just a modified version of the example database or the example warehouse that you can deploy. So if I go back to the workspace, sorry, go back to the experience, I can create a sample warehouse. So I can give my sample warehouse a name, create it. It's going to create some tables for me. It's going to load the data in. But to be honest with you, the tables weren't really named that well to my liking. So I've essentially created a script that does exactly the same thing, but just has dim and facts, which is more relevant for me. So I'll run that. And while we are waiting, I will go to GitHub. I will go to repositories and Fabric Warehouse SQL Tools. So that's github.com/data high. And then the repositories Fabric Warehouse SQL Tools. It's in a folder called Query Insights because that's what I was testing. But there is a script called O1 create and load sample Fabric Warehouse. So this is basically doing the same thing that sample warehouse is doing. It's just, to my mind, named a bit easier, as in warehouse terminology, facts and dimensions. Okay, so we can see that essentially, there we go. We've got some tables. I'll click on one of the tables and we've got some data, right? So we can start to query. We could use Power BI to start visualizing that data. But I want to switch to another way of working with the service because, yes, this is all well and good. But the fact is, I've got SQL queries in the browser in a service. Not the best in terms of code repeatability. So we can switch to Azure Data Studio. We can install a plugin. So if I go to extensions and work with, oh, there we go, SQL database projects. Okay, so currently on v1.4.2, I think Fabric warehouses became available in something like v1.3.8. Don't quote me on that. But if you've got an old version of the SQL database projects, well worth updating because it gives you the ability to work with Fabric warehouses. So in terms of a database project, I have already got a database project that I've created. I've got some tables, okay, not very many, a couple of dims and facts. Of course, this database project can be used with anything. So if you've got your own, metadata driven SQL based warehouse logic, yeah, fine. It's just a database project. I've got a stored procedure as well in there as well. I can target a specific platform, and I've got Synapse data warehouses in Microsoft Fabric. I very much appreciated when this was added a little while ago, serverless SQL pools. But there we go. So Synapse data warehouse in Microsoft Fabric. I'm just going to very quickly build that project. We should get that running pretty quickly. There we go. Build succeeded. Now I can deploy. So I'm going to right click. I'm going to publish. I'm going to select my connection. Now, here we go. So server is that connection string. So from that warehouse, we copied that connection string. That's the server. Just like a regular SQL server and Azure SQL database. I'm going to log in with MFA, select the database that I want to basically deploy the project to, which is telemetry analysis. Connect. and I'm going to click publish. And this does just a regular database deployment process. Look, a DAC pack. So if anyone is familiar with database deployments, we're still using a DAC pack. We're still using that schema and objects created in a file. Then SQL package is going to be being used behind the scenes to compare the destination database or warehouse with my DAC pack. Now we failed. Actually, a good failure to have. Some of the new functionality that's available within the warehouse are some query insights, DMVs. Now, these query insights DMVs allow you to query the warehouse and pull out some useful statistics. When I've created my database project, I obviously don't have those DMVs locally. At the moment, they are causing a problem if I've got a published profile that says drop any objects that are not in the project. So I'll right click. Let's publish again. Go through the connection. And this time I'll just go to advanced and I will say drop objects not in source. And we'll click publish again. So we'll wait for that to run. And again, yes. So as we were saying, DAC pack. Standard DAC pack deployment. There we go. DAC pack has succeeded. And if we go back into the warehouse service, I'll go into my other empty warehouse, which was my telemetry analysis. Look at my schemas, look at DBO, expand tables. And we've got our four tables. So we've got our 3-dimension tables and we've got our fact tables. No data in it, no data in, so we can get some data in there. I'll go back to Azure Data Studio. I'll open up one of my notebooks. Let's connect up to my warehouse. And I can use that copy into command. So I've already got some reference data stored in a data lake, and I just want to bring that into the warehouse. Yep, so I'm going to run that. Excuse me. And there we go, 4,000 rows. And there's just an example of some of the data that we've got in there. Carrying on. Yes, look, we've got some singleton inserts. Let's see how long this takes. So if we run it. Okay. 0.8 of a second. Performance is improving. There we go. We've got the data in there. And a method that I like to use is if you've got a warehouse in a workspace that has a lakehouse, you can use the standard 3-part naming convention, so database, schema, table, to load data from a lakehouse. Now, this works really well in configurations where you've got maybe a lakehouse and a warehouse in the same workspace, because I can essentially just query that lakehouse. At the moment, we can't query a lakehouse in a different workspace using SQL. We could use pipelines or we could use data flows to move that data around. But I'm just going to let that run. I don't know how long that takes. That takes probably 3 or 4 minutes to run, but I just want to run it anyway. Now, we touched on some of those extra features that got added because of the technology that we're using. So Delta Lake. So if I have a look at my Explorer, I'm going to look at the table cloning functionality. Now, in terms of the warehouse, we've got a table called dim event. Pretty simple. There's only 3 rows in it. That basically, it's my test data. to do with web analysis. So a customer puts something in their basket, they're browsing a product, or they purchased a product for funnel analysis. It's just my data set I use to test with. I can change that data in that table. I can also clone it. So if I wanted to check something before I actually did a table modification itself, I can clone that table. So if I go back, I'm going to create table dim event development as clone of dim event. So let me run that. Now this is essentially a metadata operation. It's not moving any data around. That's the concept of this shallow clone. And in fact, if I switch to Azure Storage Explorer and I've connected to the workspace using the OneLake URL, if I go in, I'm going to have a look and see which is my warehouse. Here is my warehouse. So there's that dim event table, right, that got created. So I can browse into it. There's the Delta log. I can go into folder structures, and there's the data, right? So those 3 rows are sitting within that Parquet file. If I go back up, there we go, development. Hey, it looks like a completely separate table. The metadata is, but actually it's still pointing to that same Parquet file. Very, very lightweight. As we start to modify data in the table, it does not affect the base table at all. So if I come back here, let's update that data. I'm just going to update that snapshot table. And oh, look at that. I haven't added a where clause. So I've updated all the data in that table. If I scroll down, I've got my original cloned table, separate copy of that table now. And I've got my cloned table where I've updated the data within that. So I think the last thing that I wanted to cover was the world of constraints. And I realized that my camera has frozen. That's Logitech for you. So I'm just going to have to leave it for the time being. So in terms of relationships, if I open up another one of my notebooks, I can create unique keys. I can create foreign keys. Now, anyone familiar with databases understands that if I define a unique constraint on a particular column in a particular table, that column cannot contain duplicate values. If I add a foreign key from one table to another, the value must exist in that reference table to be able for this foreign key to exist. In the world of the Fabric warehouse, yes, we can create a unique key and we can create a foreign key. The problem is they are not enforced. And that's why we've got this not enforced option here. I'm actually just going to see if I can just open up the camera hub and just put that to one side. No luck, unfortunately. So it's not enforced. And that means that you could introduce duplicates into the table. You could have a foreign key from a fact to a dimension where the dimension didn't actually exist. So uniqueness and foreign keys, they have to be essentially managed in the loading process. So why create them? Well, it helps the optimizer, because if you're searching for a particular value, once it's found that particular value, it knows there's not going to be another instance of that value because you've said the column's unique. Same thing with a foreign key. If it finds a join, it knows the value is there. So it's all to do with helping the optimizer. So I'm going to create those foreign keys. From my fact table. I seem to have a bit of an error. That's okay. let's have a look at the system tables. So we've got the information schema available to us. So I'm just going to run that. And we don't have any in there. So I think something's not gone quite right with the tables. Let's just have a look one by one. I don't know why resolve and merge editors appeared. I'll tell you what, I'm going to take my three. I'm going to go up to my Synapse warehouse. I'm just going to run these independently. Okay, so there's already an object. So let's run this one. Okay. Seems to have a problem just at this moment being able to run and create foreign keys on there. Not a problem. What we can do is last thing we'll do is we'll just have a look at the model itself, or the semantic model, or default semantic model that gets created. So if I switch to that model, we can see that we've got our tables. So we've got our facts and dims. Now, if those unique keys and foreign key relationships had been created, we would actually see those relationships in our model view. But just for the time being, I'm just going to ignore that and skip to a new report. Okay, I'm going to add these tables to this default semantic model. And we've got the report interface that comes up. Okay. So and we've got a problem when we've created these unique keys. Not a problem. So let's just have a look and see if we've got data in our fact table. Okay. So I think there's something wrong with loading that fact table. So let's have a look at the dim event table. Okay. So I just want to show that we've got some data in there. And then if the fact data had been loaded, we could start using it with the fact data. So I'm just going to switch back to PowerPoint slide. So what I'll do is I'll make the PowerPoint slide available. I'll just save it to PDF and put it out on to Twitter. So my Twitter is Mr. Andy Cutler. And there's loads of articles here. If you want to look at the warehousing service itself, we've got, well, Fabric decision guide at the bottom, using the lakehouse, the warehouse, or real-time streaming. We've got the data warehousing itself. Important documentation is the T-SQL surface area. So this is essentially what limitations we've got in running SQL. What features of SQL are not available? So definitely check that out. Make sure that you're comfortable with what it has, what it hasn't, and any workarounds that are available. But there are some great articles as well about parallel data warehouse. So I love James Serra's blogs on PDW because it's got all the information about that software in there. So I think I'm going to wrap up now. I think we are basically bang on the hour, and I can see Dwayne. Hello, Dwayne.
Hello, Andy.
Hello.
Yes, I noticed your video did freeze, but thankfully it wasn't in a strange facial expression or anything like that. So we're all good.
No gurning, just a very stern and
very
serious
stern, very serious about Microsoft Fabric.
It's a serious business, you know.
Well, very good. Thank you very much for your session. That was very informative, very helpful. Great, great. I like how you brought into the differences between using Fabric Synapse Analytics versus the traditional Azure Synapse Analytics. So those are very good to know where the possibilities are for people to use it, especially from a cost perspective. because
I think,
obviously you're
yeah,
going to
and
be
I think
doing very big. You're going to be doing very big data warehousing and things if you're going to use the Azure Synapse Analytics, where you can do a lot more efficient and quicker here with Fabric. So
exactly, and it's just important to know what it isn't for and what it can't
yep,
do. Right? Yeah,
exactly,
this is not SQL Server. This is an analytics and warehousing service.
exactly. Well, great. Well, thank you very much, Andy, and thanks everybody who tuned in. Obviously, we run Cloud Lunch and Learn sessions just about every Wednesday. So go to cloudlunchlearn.com to see what sessions are coming up for July. And Andy, again, thank you very much for an excellent, informative session, and I hope to see you again soon.
Yes, thank you very much. Everyone, have a good day.
Yes. Have a great day, everybody.
Bye bye.